Hello, this is Dr. Hux. We're doing Module 10 this week. We're going to do a little more on regression and a course project. We're going to be determining the prediction equations for a regression analysis, well, actually analyses. We're going to determine that prediction equation for both the simple linear regression and the multiple linear regression. And then you're going to begin writing for real the analysis of data section for Chapter 4. So we're going to start. It's time to get serious now. Simple linear regression, let's look at that. This will be pretty simple, especially for all you folks that paid attention in college algebra or even high school algebra 1, because we're going to be using this equation you see here in the middle here. Y is equal to, and if you remember, it was mx plus b. For some reason, they write y hat a little differently. And they use the constant term first, and then they do the slope, and this is the y-intercept, if you remember, when it's in the form y is equal to mx plus b. But that's what we're going to try to derive from our data. We're going to get the very best equation we can, and we're going to make predictions using the equation. Here's a set of data, and this is about the pounds in weight lost after hours walked each week. So these people, looks like there were 18 of them, spent 3.5 hours a week over a period of time, on average, walking, and this is the weight loss. So we want to know if those two are related, if they're correlated in any way. Well, of course, I think they're going to be correlated, but how are they correlated? What's the regression on this? So here's the walking hours and the weight loss. Now let's go next. It's pretty simple to run. There's your data, and then you just go to Analyze, Regression, and Linear. Now we're not doing any of the pretest. Right now we're assuming that all the pretest values are good, and most of the time they are. So we're going to do that, and we'll go through that process, and then we'll get to this page when we click OK. You'll have walking hours. If you notice, there's walking hours and weight loss. It's got a place over here for the dependent variable and independent variable. Really simple. What do you think depends on what here? Do you think walking hours depends on weight loss, or does weight loss depend on walking hours? Well, let's just call weight loss the dependent variable. See what happens in this thing. We'll name weight loss. We'll click on it like this, then we'll put it over here in the dependent variable, and then we'll put walking hours in the independent variable, and we're not going to mess with anything else right now. We're just concerned about coming up with this equation. We're not going to talk about all these other possible statistics. And then we're going to press OK. And when we do, these four tables are going to pop up. You've got what you need. I promise you do. This one up here is more appropriate in a multiple regression. It tells what's in the regression, what's not. But we'll talk about these three tables. The model summary table has your R value and the R square value. And we've talked about those before, but R gives you the value of the correlation, the Pearson correlation. And this is 0.624. That's not weak and that's not strong. That's called a moderate correlation. R squared tells you the strength, not the strength, I call it the strength, but it tells you the percentage of the dependent variable that's as a result of the independent variables. And here, 39%, it looks like, of the dependent variables whereabouts in the schematic of things here is dependent on the independent variables. An adjusted R squared, that depends on the number of degrees of freedom you have, and it's kind of like you got to find for doing this. You didn't have enough values, so it's really 0.352. So they've got a little exponential way of taking some points away from your R square, and it doesn't. I don't know that it really matters which one you use. I guess adjusted R square is the best one to use. The standard error of the estimate is 0.94532. Now, you've got an ANOVA table. Now, the really important table down here at the bottom, that's the one we're looking at. But we really can't do anything with that table until we know that this significance value right here is less than 0.05, and it is. We really don't care anything about the rest of this right now. We don't need it. Now, since it is, we'll go down here and look at the coefficients. Well, what does that mean? That means the coefficients in the regression equation. And here they are. This thing B, these are where you find your coefficients. This first one, the constant, that's your y-intercept. and the next one is the coefficient of x. Let's see what that looks like. Here's the regression equation, and here are the values from this table down here. Let me find them here. Here they are, plugged in to this thing. Minus 0.120 is the y-intercept. That's the constant term. And the slope is 0.346. You can see that down here in the table. So you put that in, and you have an equation. Wow. Now, if we can make a prediction, if we walk 6 hours, we can predict for a week, we can predict a weight loss of, we put that 6 in, 6 times 0.346 minus 0.120, 1.95 pounds lost that week. That is if you don't eat anything else and you just walk. Okay, multiple regression. And now this is a more powerful test, but it may not turn out as well as the simple regression does. But multiple regression is just what it says it is. Instead of one term with a variable, like B0 and B1x, like the simple regression, we can have other terms out here that are linear. You don't see anything squared there, so they're all linear. So we're looking for an equation like this. Well, here's what we do. Here's a set of data. This is about being sick with the flu, and this column tells you how many days you were ill. Let's just call it sick. We're from Arkansas for the most part. And does that depend on gender? Well, they thought it did. So they've got 1 male, 0 female. Flu shot, whether you have one or not. If you have a 1, you had the flu shot. If you don't, you had 0. Chronic disease, are you a person that has a chronic disease? Well, if you do, it looks like you get a 1, and if you don't, you get a 0. And the age is that's a continuous variable there for the most part. These others aren't. Let's see what happens. You go to analyze, regression, linear, same process. You put in flu, sick, that's how many days you were sick. And that's you see, that's a continuous variable. Then you can put it, this thing we can deal with here, we can deal with variables that aren't continuous, like the flu shot, yes or no, gender, male or female, chronic disease, yes or no. Well, and you don't see it here, but down below this is another one, the fourth one, age. So there are 4 of those. Well, let's see what happens when we run the test. We're going to click OK. Okay, we get the same field that we had before. We get the variables, which age, gender, chronic disease, and flu shot. Those are the 4 variables. Now, the model summary. R, again, that's a middle of the field correlation with 36.8% of the dependent variables can be accounted for in the independent variables. And here's an adjusted R square, which means we got fined a little bit for not having enough pieces of data. Standard error, there it is. Now, let's look at the ANOVA. What's important here? Oh, this number right here. Highly significant. So something is going on there. So we can go down here now, and we can look. Here they are, the constant. In that equation, here's your y-intercept, 4.1. Here's the gender coefficient. Here's the flu shot coefficient. Here's chronic disease coefficient. Look at that. That's negative related. We don't want that in there. 0.024. Well, let's see what we've got here. This is what's important, the significance. If you look here, you see that gender, not significant. Doesn't matter if you're a man or a woman. The flu's the flu. And down here, chronic disease. Now, see, if I were to guess, I would have thought that would have been significant, but it's not. So the only 2 things that were significant here in this equation were what? Flu shot and age. So we really wouldn't want to write a 4 value equation with a y-intercept having 5 terms in it, because 2 of these aren't worth a darn. So what we would do is go back and run this again. In other words, we would take out chronic disease and what was the other one? Gender. We'd take those out. We would only run this with the flu shot and age in it, because those were the only 2. Let's see what happens when we do. Well, look here. We've got 0.602. Didn't help it much. R squared about the same. Significance about the same. But let's look down here. We have a high amount of significance in our 2 variables. Flu shot, highly, highly significant, whether you get the flu or not. And age was about 0.02, which is highly significant. Let's see what kind of equation we're going to have. You see this? This is the y-intercept. Here's a multiplier for the flu shot. Here's the multiplier for age. Let's see how that works. Here's the form of the equation because it only has two variables in it. What were the two variables? Age and flu shot. So y is equal to b sub 0, b1, and b2. And the y-intercept, here it is, 3.515. That's that top number down there. The next number, the 3.313, that's the, the value of having a flu shot or not. So that's going to be yes or no, 1 or 0. So then the next thing was age. So you take whoever's age you want to check on this, and if they've had a flu shot, you can find out what the number of days they could be sick. Now, here's the deal. If you check with the flu shot of a 28-year-old, we put all those numbers in and we got 14 days. Now, something tells me that there's something wrong with that. You know what I'm thinking? I'm thinking that if you got a flu shot, that probably should have been 0 for X1. And if you didn't get a flu shot, it should be 1. So really what I should have here is 3.515 plus 26% of 28. What is that? 3 times 3 is 0.91. So that would add up to about 4 days. So my calculation, I didn't pay attention to the setup on this because I think if we went back to the data, we'd see 0 is when you have a flu shot, that's going to be 0. When you don't, you're going to get kicked with this other thing. So that's what that's about. You got to pay attention. Here's your problem you're going to have to work, and I've given you a template to go by it. I'm going to give you, see this right here? I'm going to give you height, weight, and gender. And you're going to do two things with this data table. You're going to do a simple linear regression. You're going to compare height and weight in a linear regression, and then you're going to compare weight, height, and gender in a multiple linear regression. You're going to use the same data. You will have to put this data in SPSS, so you'll have to figure that out. The problem is here it tells what the problem is. You're going to be required to make a simple linear regression. Now, I have a template in here, and you don't have to worry about what do I do next, because if you follow my template, I don't have the next page on here. First thing is, what's the dependent variable here? Well, it's weight, obviously, and the independent variable is going to be height. And then when you get the multiple linear regression, you're going to have 3 of these things here, and you have to figure out what goes there. Not bad at all. You'll be able to do it. Course project. This is important. Course project is you're going to do the analysis of data section for chapter 4. You are going to write that formally just like you were going to turn it in for part of your dissertation. And these ABCs, these are a hint as to what things need to go in the analysis of data section. You won't find any tables in here or anything like that. Well, you will too. I don't know what I'm thinking. I'm thinking of the last thing we did. But A, B, C, D. I'll give you an example. I've got a template for you to follow. Here's an example. If you'll go back, you'll see the first thing said, first appropriately centering the heading analysis of the data on the paper, presenting an opening paragraph, next state the null hypothesis. So I've given you the procedures, kind of like a cookbook recipe, and there's nothing wrong with that. So here it is centered, opening paragraph. You better look at some analysis of data sections and see what they write in. I've given you a couple of good dissertations. The one that Christy Vincent's, look at it, see what it has in there. Then you write your null hypothesis and you write it. There is no significant difference. There is no way. You don't say there will be or there was or anything like that, because a hypothesis is what it is. And then the hypothesis 1, this was already analyzed by one-way, well, was analyzed. So that's what it says over here. Hypothesis telling about it in part D. And then here's the table for all that. Here's the F1, the table, and what we have for that. So that's what you're going to be doing. And there are videos to show you how to do all of this stuff. So good luck.